we want to determine if this relation is a function. So let's go back to our definition of a function. Remember, a function is a relation in which every input value corresponds to only one output value. So remember, you can kind of think of it as like a little machine. My lovely artistry here. We've got this little machine where we're going to put values in. Okay, so for example, look at this first ordered pair here. We're putting the value of 1 into this function, and the function inside, whether you wanted to call it the function f or f of x or h of x, doesn't really matter, but your function is going to do something to this number 1, and out pops the value 2. Okay, so when I put in the number 1, if I'm only going to get out one output, only one output, then it's going to be a function. Okay, so we know we put in 1 and we get out 2. So we now need to look at my other ordered pairs. Do I ever put in 1 again and get out a different value? And you'll notice out here, I do. I put in 1 and then out pops 4. So that's going to fail. This is not going to be a function because for the input of 1, we have 2 different outputs. We have an output of 2 and we also have an output of 4. Okay, so you want to be able to answer the question yes or no, is it a function? And in this case, your answer is going to be no, it's not a function, but you also want to be able to answer why. So this is not a function because the input value of x equals 1 has 2 different output values. So again, it's not a function because the input value of x equals 1 corresponds to 2 different output values. So be sure that you can actually write in a sentence your argument as to why or why not you think a relation is a function. Now remember, you also have kind of a visual approach that you might prefer. You could look at this graphically, so you could go ahead and actually plot the individual points that we have. So we've got the point 1, 2, -1, 3, and 1, 4. These are all supposed to be closed dots. Sorry, my pen's not letting me close those in. Anyhow, you can look at your relation graphically, and then you see that we have 2 points here that lie on top of one another vertically. In other words, if you draw a vertical line, this vertical line is going to touch 2 of the points. And so this is your vertical line test, and you can see that this relation fails the vertical line test, which is another reason why it's not a function. Now let's look at B. Is this relation a function? So again, we'll look at the individual inputs. We put in the value x equals 1, and we get out the y value of 2. So do we ever put in x equals 1 again and get out a different y value? And the answer is going to be no. Okay, so once again with my little kind of lame visualization of this little function machine, but it might work for you. You're going to put in a value of 1 into your machine and you're getting out a value of 2. Again, you're only getting out one output, only one. Okay, and so then you do it again. For the next ordered pair, we put in a value of 0 and it pops out as a value of 2. I only get one value out. And then the same is going to be true for my last ordered pair here. So this one is going to be a function. Yes, it's a function because every input corresponds to only one output. And again, if you wanted to look at this graphically, very quickly you could get a nice visual by plotting your points. So 1, 2, 0, 2, and -1, 3. And you can see that these 3 points will pass the vertical line test. Part C, is this relation a function? So this time the relation is written in equation form instead of just a bunch of individual ordered pairs. So we want to know if this is a function. And there's a few ways of approaching this. One way would just be to approach it by making a table. This is called looking at the problem numerically. Let's just look at a table of values. And let's pick some values. So let's say you picked an x value of 0. So you would have 0 is equal to y squared. So we know if we square root both sides, then my output would just be 0. But it's always a good idea to look at more than one point, because if we stopped and just looked at 0, 0, then we would think this is a function. But we really aren't sure until we look at a few additional points. So say you tried x equals 1. So 1 is equal to y squared. And then you go square root both sides to undo your quantity squared. And perhaps you remember from a previous algebra class, then this is going to result in a plus or minus. So we're going to get two different values. We're going to get y is equal to plus or minus 1. In other words, we've got a value of 1, but we also have another value, y value, of negative 1. Another way to say that would be to look at these individual y values. If I take the y value of positive 1 and I square it, which is what the relation is telling you to do, then you will get out an x value of 1. But if I take negative 1 and I square it, I'll also get out that x value of 1. So now taking a look at this part of your table here, you can see that when I put in an x value of 1, I get out two different outputs. So for that one input, I have two outputs, which is a problem. That's why this is not going to be a function. Now, if that doesn't work for you, you also could think about this graphically if you have a little bit of knowledge of what the relation might look like. So you might also consider solving this equation for y. So if we solve for y, we would square root both sides. So that would give me plus or minus the square root of x is equal to y. You would probably rather write that as y is equal to plus or minus the square root of x. So if you have an idea of what the square root of x looks like, you could go ahead and generate its graph. So we know the square root of 0 is just 0. The square root of 1 is 1. The square root of 2 is a decimal. The square root of 3 is a decimal. The square root of 4 will give us positive 2. So we can generate the graph. It's kind of half of this sideways U shape or a sideways parabola, and that's going to be the positive square root of x. Therefore, the negative square root of x is going to give us the bottom half of this graph. It's reflecting over the x-axis, so you can see that it's going to fail the vertical line test, so that's why it's not a function. So again, this is not a function because when we input the value x equals 1, we get out two different y values. Or you could say it's not a function because the graph is not going to pass the vertical line test. Part D. So now this is kind of a non-math example, but I love this one because it really tests your knowledge and your understanding of the idea of a function. So my domain now will be all the students in our college algebra class, and our range will be hair colors. And the question is, would this represent a function? So again, going back to that kind of machine idea, to test whether you have a function or not, you want to look at one input and then decide if there's one output or if there could be two outputs. So you pick one value in the domain. So we're going to pick a student in our class, okay? So you're saying in goes a student, just one student. You could call it student A if you wanted to. In goes student A, and the question is, what are the options for hair color? Is student A going to have just one hair color? Okay, so let's say student A just has brown hair. Or is it possible for student A to have brown hair and, let's say, blonde hair? So is this a possibility? Could one student have two hair colors? And hopefully you're going to say that yes, the answer is yes, you could have a student with multiple hair colors. If they had highlights, let's say, or if they're like me and they're going gray, it is possible to take one student in our college algebra class and get out two different hair colors. Okay, or maybe they got their hair, dyed purple. So they've got purple and red hair. So this is not a function. So the reason why is that one student could have two different hair colors. And finally, our last example. Let's say the domain are all the students at MCC, and the range are social security numbers. So again, the question is, when you input one student at MCC, Do you get out one social security number, or could you possibly get out two social security numbers? And so hopefully you're saying you would only get out one social security number for each of those students. Therefore, this is a function. So this is going to be a function. It is a function because every student has just one social security number. Every student has only one social security number. Beautiful.